right. So a step function, so if I write down mu of t, right? A step function is 1 when t is greater than 0, and 0 when t is less than 0. So are you integrating forward in time? Did anybody integrate backwards in time? No. Everybody integrated forwards, which means mu of t is? So you set that to 1, and the problem's not as difficult as you think. So let's not do 20. Is that okay?
How about 20b?
I heard a 21c, and then I heard a, now I hear a 20b. 21c. Do I still hear 21c? What about 21a?
Yeah, that had that 1 plus 1.
All right, what's the difference between 21a and 21c? They're both second order. The forcing
21a has an imaginary number.
Okay, 21a has imaginary roots. What about 21c? What's hard about that? 21c has imaginary roots. I would say if 21a has imaginary roots, I would do that one because the forcing function is more complicated, don't you think? The sine function as a forcing function is more complicated. So can we do 21a? All right, let's do 21a. All right, you guys read it off. Is blue okay? Should I do black?
Probably black.
Let's go black.
Black?
That blue would be hard to see because there's layers on the board.
Yeah. All right, 21a. What's the problem? X double dot plus
2x dot.
2x dot plus 2x equals
Sine of 2t.
sine of 2t.
And then x of 0 is equal to
Go ahead. I'm
x
listening.
is equal to 2 and x dot of 0 is equal to
So you got to do your homogeneous solution with r squared plus 2r plus 2.
Should just put this in manual focus here. There we go. All right. So let's do it. Let's forget about our initial conditions right now. Let's do the homogeneous solution. So x double dot plus 2x dot plus 2x equals 0. Now we're not fooling anybody. You're going to get a characteristic equation, right? You don't need to assume a solution and take two derivatives. You know you're going to get what for a characteristic equation?
2 roots.
Yeah, you're going to get two roots. But what is the characteristic equation? R squared plus 2r plus 2. Okay, and then what? Find the roots. Can I factor this, or is it, do I have to use the?
Quadratic.
I got to use quadratic. Okay. So r1 comma 2 is negative b plus or minus square root of b squared minus 4ac. Really? C is 2, so an 8. My bad. All over 2a. Okay, so I get negative 1 plus or minus, that's square root of negative 4, which is
2i.
just 2.
2i. After you solve it, you get 2i.
Yeah, just get I.
Yeah, you just give me negative 1 plus 1.
All right, there are my roots. Okay, so I plug this into the assumed solution that I didn't write down, but I guess now let's go ahead and write it down. My assumed solution for the homogeneous solution is C1 e to the R1t plus C2 e to the R2t. And what's R1 and R2? That's these guys over here. So there's my homogeneous solution. Okay, do you need to factor this out into cosines and sines? You could, but this is still technically right.
Doesn't it have to be e to the negative t times c1 cosine of t plus?
That's if you use Euler's. If you use Euler's, you'll break it out into cosines and sines, but you can just leave it like that. There's nothing wrong with an imaginary number and an exponent. Anybody taken complex analysis before? No? They don't teach that at the undergraduate level? Mike's like freaking out.
I've taken it.
You've taken it,
Yeah.
so it's an elective.
Yeah, it's a complex analysis like the math class.
Yeah, and how long did they spend on imaginary numbers and exponents? Like
I mean,
a month?
it was maybe like the first like fifth of class, and after that it was just nothing but very complicated stuff.
Yeah. Anyway, I'm okay leaving it like this. All right. So, anybody have any questions about this, or can we move on to particular? Austin, you all right? Got a question? No. All right. What about Justin? You all right back there? What are you playing? All right. What do we got? Particular solution. X particular of t equals what?
A sine 2t plus
A sine 2t
plus b cosine 2t.
plus b cosine 2t. Two questions. How did you know there was a sine 2t over here?
I took derivatives.
Of what? Because there's a sine 2t here, right? Whatever is here, you multiply it by, you ignore the coefficient, and you multiply this by an unknown, and you put it in your particular solution. Okay, Dylan, how did you know there was a cosine in there?
If you take the derivative of sine a bunch of times, you get cosine.
You take the derivative of sine, you get a cosine. Okay, turns out when you do the particular solution, you need to take the function itself, take a derivative, make that part of your particular solution, take the derivative again, make that part of your particular solution until you get to 0. In this case, it just keeps looping back and forth, so you just need a sine and a cosine. Cool beans? Or
I thought Prokhorov taught that when you have
Prokhorov.
in particular you have D, one of our D answers. So when you have a sine or a cosine in your particular solution, you immediately take out like your R or your beta is equal to 2 in this case, and so then you just plug it back into the A1.
you can. He might have taught you a trick.
Yeah.
I don't want to do that. 'Cause I'll be wrong. This is assuming nothing here. This is like, I'm just going to try it and see if it works. If it doesn't work, the math will tell me.
It's the same thing. It's just
Okay.
when we had a sine or cosine, we immediately just had used the sine and cosine.
That's fine. The rule is take your forcing function and take derivatives until you get to 0, and all of those need to be in your particular solution. So if you have in 20c, when you have t squared, you need at squared plus bt plus c in your particular solution. Did everybody hear that?
Yeah.
Okay. All right, so we're going to take a derivative. So we got 2a cosine 2t plus negative 2b sine 2t. Take another derivative, x double dot p of t, 4 negative 4a sine 2t minus 4b cosine 2t. Yeah?
Yes.
Yes? Yeah? Oh yeah, the dots? Yeah, I need to make those big, don't I? What if I do like hoops? Is that like too weird?
Little smiley.
Smiley? No, come on. I guess I could do like lines, whatever. This is fine. I'm gonna do hoops. All right, what do I do with this?
Plug it back in.
Plug it back in. So I'm gonna get a negative 4a sine 2t minus 4b cosine 2t plus 4a cosine 2t minus 4b sine 2t plus 2a sine 2t plus 2b cosine 2t equals sine 2t. Okay, so this is x double dot. This is 2 times x dot. This is just 2 times x. And this is our forcing function f. See, I'm hearing a lot of silence. Anybody have anything to add? You guys okay? Okay. All right, what do I do now? Separate the sines and the cosines. So what I like to do, I just like to put sine 2t over here with a colon. And then wherever I see a sine 2t, I throw a slash in it and take the coefficient. So negative 4a, no, no, yes. Negative 4b, yes. 2a, and then no, and then yes. So that's equal to 1. So this function is what? Negative 2a minus 4b equals 1, right? So let's go ahead and do the cosine. Well, I'll let you write it down. Let's go slow here. All right, what are my coefficients for cosine 2t? Negative 4b
Plus 4A,
plus 4a
plus 2B.
plus 2b. Okay, what do I do? What do I do here?
Equals 0,
Just 0? How do you know that?
because there's not a cosine.
So there's not a cosine over there. Okay, so what's this equation? Negative 2b plus 4a equals 0. How do I solve that? Just system of linear equations, so negative 2, negative 4, 4, negative 2, ab equals 1, 0. Do I expect you to solve this on a test? No. If you write that and square it, I assume that a computer could easily solve that. Oh, what? The brackets are a matrix, the parentheses are vectors, the box is saying that's my answer.
What about solving for C1 and C2?
Yeah, what about solving for C1 and C2? So we still need to do that, right?
I mean, you have
We
to
have to find A1 and
You can just keep them as variables though and let MATLAB solve them for you. Because I told you to do this on MATLAB, right? So that's the next step after
A. And
this.
solve it by hand.
Yeah, so you're solving it by hand.
You have to have A1 and A2 in order to find.
Okay, so take the inverse and then write down A equals 0.34. I didn't say you couldn't use a calculator. I just said you had to solve it by hand. That means you have to write it down. This isn't ME analysis, this is controls.
I just did it the old-fashioned way.
You did the adjoint divided by the determinant?
No, I just did it in algebra.
Substitution?
Whatever that word is.
That's fine. I'm going to leave it like this.
I think you should write, if you have imaginary roots, you should write it the other way, because what if you have repeating roots with a particular?
It's a different
If you have repeated roots, and it's a different form.
If you have repeating roots,
If you have repeated roots, you have C1 plus C2 times T e to the RT. You have that. If you have repeated roots, that's